So today we're on 3-2, solving systems of inequalities by graphing. So like we already talked about, it's the same thing as graphing a line, except for this time it's going to be dotted or solid, and you're going to shade somewhere, just like before. On this first one, they were already in slope-intercept form for you, so it should take you like 2 seconds. So on the first one, on number 2, 3, whatever that says, this isn't working. There we go. Where do I start? Up 4 on the y-axis. Put a dot, and then what? Down 2, right 1, or? Up 2, left 1, right? Because our answers were the shading overlaps and not an ordered pair. Yesterday it was an ordered pair because it was equal signs, right? Today it's just the shading. I don't have to have a super accurate graph. Just 2 dots is good enough, okay? So is that dotted or solid? Dashed line, or whatever you want to call it. Where would I shade? Above, because it says that, right? So here's where the idea is simple, but you just need to figure out what works for you. I'm not going to shade all this stuff because it's kind of hard to erase on this thing, but you could shade it really light with a pencil, or you could also use colored pencils and just 2 different colors, and where the colors overlap is your answer. So you need to do whatever you want. I'm just going to do a little like squiggle, so I know I'm shading there, but I didn't actually do it. Does that make sense to you? Okay. On the second one, where do I start? Down 3 on the y-axis, and then? Down 3 right 1 or up 3 left 1. So I'm going to go up 3 left 1 quite a bit until they cross. So up 3 left 1, up 3, is that 3? 1, 2, 3 left 1, 2, 3 left 1, 1, 2, 3, 1, 2, 3 left 1, left 1. So dotted or solid there? Solid. Above or below? Below. So it was, I'm going to extend this line, okay? So it was above this line, and it was below this line, so my final answer is there. Do you guys understand that? Okay. So on yours, on your homework, you might want to use my 15 by 15 graphs, which is what you grabbed over there today. It's just kind of easier and it fits better. I think this is only a 10 by 10 or something like that. Do you get how easy that is, though? If it's in the shaded region, it's a solution. If it's not, it's not. So is the origin a solution here? No. I'm not going to try to guess where that is, but if it's in here, it is. If it's on a solid line, it's a solution. If it's on a dashed line, it's not. Do you guys get that? Okay, great. The next one, we're going to come back to that one. It's a little bit harder, I think. So we're going to go to 29, okay? Again, the graphs don't have to be perfect. What I mean by that is they're not asking us where they intersect. It's just the shading that's the answer. So this graph is going to be fine. Your sketching of a graph is going to be fine. With this one, let's start with the top. That's y greater than or equal to, that's technically negative x plus 6 in the absolute value. So you guys get what I just did? Do you at least get that that's okay? All right. What shape is that going to be? A V, right? If the negative hadn't been there, pretend the negative's not there, where's that V going to move? To the left 6, right? But that negative is inside the absolute values in front of the x. So if it were here, it would be a flip over what axis? Would it be a flip over the x-axis this way? Or would it be a flip over the y-axis this way? It'd be the x-axis, right? It'd be flipping, I guess you'd call that a vertical flip, right? But because the negative's here, what's that flip? A y, right? So you guys said left 6, but if I flip it over the y-axis, it's really right 6. Do you understand that using our tricks? Let's pretend you didn't, right? We can do a t-table, no big deal, okay? So instead of telling myself I think it goes right 6, right? Let's just do a t-table. I'm going to save you some time. Let's do 4, 5, 6, 7, and 8, okay? You can always do negative 2 to 2, but to save time, it's not going to be helpful to go over that far. So if I put 4 in, what's negative 4 plus 6? 2, absolute valued. 2 still. 5, negative 5 plus 6. 1, absolute valued. 1. Negative 6 plus 6? 0, absolute valued. 0, very good. Negative 7 plus 6? Negative 1, absolute valued. 1, what do you think 8's going to be? 2, very good. See how we've got the V? We've got it symmetric. So that really is moved right 6. 1, 2, 3, 4, 5, 6, like that. Is this solid or dotted? Solid. Oops. Okay. Where would I shade? Above or below? above. So if I were you, I would go ahead and shade lightly here, and then we'll see where they overlap at the end. Is that okay? Again, if the shading is hard for you, let's use colored pencils. One of them's yellow, one of them's blue. When they make green, that's the answer or something, right? So this one, the absolute value is on the y this time. Whoops, that's not what it says. The absolute value is on the y. I need y alone. How do I get rid of absolute values? Anybody remember? Back when we had... what'd you do? Get the absolute values alone. So add 4, right? So what's that? 11. And then what did you do? Remember? 2 equations? Do you guys see what I'm saying? That's what we have to remember, right? So it's the same thing here, except we're going to graph a line, okay? So absolute values are already alone. So I still have y less than or equal to 4, but this time I have y greater than or equal to negative 4. Why is it greater than or equal to this time? Because you've got the negative, right? So you flip the sign. So show me on your arm what y equals 4 looks like. Is that a vertical line or a horizontal line? Y equals 4. If the y-axis goes this way, the y-line goes this way. You're right, it's horizontal line. So on 4, we're going to draw a horizontal solid line. 1, 2, 3, 4. As far over as I can. So obviously my graph, I don't have all of it, but that's okay. Am I going to shade above or below it? This one? Yeah. Below, right? So again, I'm not really going to do that, but you're going to shade technically all this stuff. So far our answer is in here. So far. Do you guys get that? Okay. Now I'm going to go to the negative 4. 1, 2, 3, 4. Solid again. And where do I shade there? Above. So pretend the V wasn't there for 2 seconds. Below this line and above this line, I should have arrows there, but you can't see it, would be just in here, right? But the V is here. So it's already in there, and it's above this guy. So your final answer is in there. Do you guys get that? Because the absolute values, whenever you have absolute values, there's really 2 answers to get rid of them. So you have to do the original problem, and then you have to change it to a negative, or take the opposite, I guess. And when you do that, you have to flip your inequality. Does that make sense, or that you need to see me later? Okay. Yeah. So I don't care how you do it, as long as I can tell what your final answer is. So if you have a bunch of shading everywhere, and this is just super, super dark, that's fine. I don't care. Or if you have yellow and blue, and you tell me that, like, where they overlap is your answer, that's fine too. I don't care. I typically just shade the final answer because I don't like it to look too messy, and it's really hard to erase on here for me. You guys okay? Okay, so we're going to go back to this one. This one wants you to find the coordinates of the triangle formed. So this one, we can't just graph it and shade it and call it a day, right? We actually need to see where they cross. So because we want to see where they cross or intersect, it needs to be super accurate. So we're probably going to end up having to use algebraic methods to solve it, but I'm going to go ahead and sketch the best graph I can first. Does that make sense? I'm going to call this one A and B and C, okay? For the sake of time, we want to put it in slope-intercept form, right? This first row, go ahead and get A in slope-intercept form for me. These middle 2 rows get B in slope-intercept form, and that last row gets C in slope-intercept form. Take a second and do that, please. It may not be pretty, and that's okay. Check it with your neighbors in your group. Okay? For A, you should have gotten y is less than or equal to 3/4 x. I put plus 3.75. You could have 15/4, but because we're graphing it, I want 3.75 for myself. Is that okay, A group? Did you guys get that? Okay. B group, you should have gotten y is greater than negative 5 halves x minus 6. Did you guys get that? Anybody have a question? Okay, great. C group, we've got y is greater than or equal to 27 over 10x minus 6. Is that okay, you guys? Great. So whatever group you weren't in, you still need to write these down, right? I'm just not going to make you all do the same math for the sake of time. Is that okay? So we're going to graph these the best we can, but obviously graphing 3.75, I'm never going to trust where they cross if I'm using 3.75, because it might look like they cross at 1, 2, but what if it was like 1, 2.2? Do you see what I'm saying? So I'm still going to sketch a graph, and I'm still going to see what it looks like, but I'm going to have to solve this algebraically instead. Okay? So on the first one, on letter A, we're going to start at 3.75. We're going to do the best we can. So 1, 2, 3.75-ish, right? And then up 3, right 4. Something like that. Solid or dotted? Solid. Above or below? For letter A. It's going to be below, right? We're going to shade below. Again, I'm not going to shade till the end, though. I'm going to go ahead and label this line A, even though that's not really its name, right? But because later it's going to get kind of confusing, it's easier if you label it now. And then the next one, we're going to start down 6. 1, 2, 3, 4, 5, 6. Okay. Down 5, right 2, or up 5, left 2. 1, 2, 3, 4, 5. 1, 2. 1, 2, I'm going cross-eyed. 1, 2, 3, 4, 5, left 2. There we go. Solid or dotted on B? Dotted, dashed, whatever you want to call it. Where would I shade on that one? It'd be above, right? So right now we're over in this area, okay? And then on this last one, you start down 6. Hey, wait a second. If I start down 6, aren't I going to use that as one of my answers, right? It crossed both lines. We'll get to that in a second. I can't really go up 27 and write 10, right? So instead, I'm going to use x and y intercepts. What we did wasn't wrong. It's just I don't have a graph that goes that big. So I already know my y-intercept is negative 6 because I just found that. Do you guys understand what I'm saying? How do I find the x? To find x, you set y to 0, right? So it's going to be 0 equals 27 over 10x minus 6. Add the 6, divide by 27 over 10, and you get like 2.2 repeating or something. So this is where algebra can get frustrating because I skip over stuff that you should be comfortable with already. So if this is something you couldn't do without me right now, you need to see me in Win, and I'll show you where I got that from. Does that make sense? But I've got to finish the problem. So I'm going to go to like 2.2. It's going to be a solid line, and it's going to be above. So here's my triangle. Do you guys get that? The 3 ordered pairs I've circled. So I need 3 ordered pairs. What's one of them? One out of those 3 is for sure not a guess. It's pretty easy. 0, negative 6. You guys all see that that one was not guessing, right? They both hit 0, negative 6, so that's an answer. So check mark. We don't need that one, okay? But these two, I would be guessing. Even if I had used a ruler and I'd put more ordered pairs using my slope more than once, I would be guessing. You can't do that, okay? So we need to see where A and B cross, and we need to see where, I didn't label it, C and A cross. How do we do that? Substitute or eliminate, right? That's the whole point of the whole chapter. You can solve any way you want to, but with this we have to do it algebraically. So I'm going to use substitution, and I'll show you why. Didn't we already get these y's alone? So couldn't I just replace one y with another y? Isn't that substitution? So for example, if I'm looking at this guy first, A and B, where they cross, right here. If they're both equal to y, can't I set them equal to each other? Do you guys get that, or do you need an easier example with like the number 2? This is what I did for my other classes. Let's see if you get it. What's 2 plus 2? 4. What's 2 times 2? If they both equal y, don't they equal each other? That's what I'm saying. That's what we're going to do up there. Okay? So this is where on the back you have some space. You might want to, the graph paper, by the way, was for you to use on this, but that's okay. It's all right. So on the back, we're going to need some space. All right? So we're going to see where A and C cross. If they're equal to y, they're equal to each other. So 3/4 x plus 3.75 is equal to negative 5/2 x minus 6. So this is where we are right now, right here. So you guys need to try to find x for me, please. If you don't understand what I just did, please say something. I set A and I think B equal to each other because they were both equal to y. X is a normal number. It's an integer. What'd you guys get? What do you think it is? Anybody? Thank you. -3. Did anybody not get -3 and need help? Are you sure? So if that's x, can't I plug it back into either of these and get y? Right? Or couldn't I plug it back into either of these and get y? Either way, it doesn't matter. You need to pick whatever you're more comfortable with. But I'm working with A and B. What do you guys want to plug it into? A or B? I heard both. Doesn't matter. Plug it in wherever you want. I'm going to plug it into B. So y equals negative 5/2 x minus 6. And what do you get for y? 1.5. So one of our answers is -3, comma 1.5. And if you look, -3 about 1.5, it looks like that could be true, right? If you got -3, comma 10, I feel like we would mess up somewhere, but you can't guess 1.5. What if that had been 1.4? Do you see what I'm saying? We don't know that, okay? So we need to find this one, and this one is where A and C cross. So this time I'm using A and C. So I'm going to set them equal to each other, the 3/4 x plus 3.75 and the 27/10 x minus 6. When you get x, shout it out. Anybody get it yet? X is 5, thank you. You can plug it back here or here. Either way. And then see what you get for y. Take your time, actually get it right. So you should get 7.5 for that one. So it's 5, comma 7.5. And again, if you actually look at our graph, that looks possible, right? 5, 7.5. That looks like that could be true. Okay? So here's my question. Is the origin a solution? Yes. Is 10, 0 a solution? 10, 0. No, right? But the actual question just wanted the ordered pairs of where these three lines cross. Okay? I have one more to add. If you have any space on the back, let's do that one. It's just real quick. I'm afraid you might get it wrong if you don't look at it. So, just call this extra example, I guess. We're going to graph y is greater than -1/2 x plus 2, and y is less than -1/2 x minus 4. This is like a 2-second example. Okay, so where do I start on the top one? Up 2 on the y-axis, and then Down 1, right 2, thank you, or up 1, left 2. It doesn't matter. Dotted or solid? Dotted, very good. Above or below? Above. So for me, I just do this little squiggle. Where do I start on the second one? Down 4, and then? Down 1, right 2, or up 1, left 2. Dotted or solid? Dotted, above or below? Below. Where does this shading overlap? Nowhere. How do we know for sure it's never going to overlap and we don't just need a bigger graph? They're parallel, right? If they're parallel and they don't overlap ever, what's your answer? No solution. Very good. Do you guys have any questions? We're going to skip the story problem for today. We'll have some time tomorrow. Are you sure? Okay.